In this video, we will see vector application of cross product in physics. A more detailed description of cross product is found in the link which is presented in the description box. So that video has a more detailed explanation of cross product, but here we will look more into the practical application of physics and a short introduction into cross product. Consider a merry-go-round. A lever is held at the axis with a certain length. If force is applied on the lever at this point, the lever will begin to rotate about the axis. The resultant force at the axis is called torque. This is measured using vectors. R is the vector of the lever and F is the vector of force which is applied, and the resultant vector, which is torque, is 90 degrees perpendicular to R and F, and it is measured using the cross product of R and F. So this picture will give you a better understanding. You see the axis here and you see the lever which is holding the axis. So as you apply the force in this direction, it will begin to rotate the axis. I have put a more detailed description of cross product in the description box below. So please watch that to have a better understanding if you have not watched that video. So here we will just quickly see how we can get the magnitude of torque. So magnitude of torque can be measured using the formula R into F sine theta. Now this is our vector F, which is the force applied. I'm going to translate this vector about the axis with our axis as the origin. Then this is the vector F and this is vector R, and this is the angle between the two vectors. So the magnitude is described by the force F multiplied by this length here, which is nothing but R sine theta, which is theta is the angle here. So this will give you the magnitude of torque. Let's do a problem. Find the magnitude and direction cosines of the torque about the point 2, 0, minus 1. So we are asked to find two things. One, the magnitude. The second, the direction cosines of the torque. So torque is always about the axis or the origin. About the point 2, 0, minus 1. So this is the point of reference of a force 2I plus j cap minus k cap. So the force F is defined by 2I cap plus j cap minus k cap, whose line of action passes through the origin. So now this is a very key statement. The line of action of force is through the origin. So what we have to do is, our point A is about where we need to find torque. So you need to, the direction of the vector R will be from A to O, because the line of action passes through the origin. Okay, so if we're going to start defining each vector, so let's call R, vector R, as A, O vector, where our point A is defined by this. So this is nothing but, what is our OA vector? Will be 2I cap minus k cap, using the points. Yeah. So now our AO vector will be in the reverse. So it will be minus OA. So that will be minus 2I cap plus k cap. Right. Next, let's find the R into F. So before that, our vector F is defined as 2I cap plus j cap minus k cap. So torque is equal to R into F. So that will be defined as the determinant of I cap, J cap, K cap. R is coefficients of I cap is -2, coefficient of J is 0, coefficient of K cap is 1, and for F the coefficient of I cap is 2, coefficient of J cap is 1, and K cap is -1. So this determinant value will be 0 minus 1 I cap. So minus I cap. Then for J it will be 2 minus 2 minus 1 will be plus 2 minus 2, so it will be 0. So J cap will be 0. So for K cap it will be minus 2 plus 1. So it's minus 2, 0. So it's minus 2 K cap. Okay. Now the magnitude of torque is which is you can square root of 1 minus 0, that will be minus 1 squared plus minus 2 squared, and that is equal to square root of 5. So that's the magnitude. Now let's find the direction cosines. So direction cosines will be coefficient of I cap is -1 divided by the magnitude will be √5, comma, for J cap the coefficient is 0. So it is 0, and for K cap it is -2 over √5. So that's our direction cosines. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.